Hi Year 12, welcome back for another lesson on our non-linear relationships topic. We're moving on to exercise 8b today, and 8b is dealing with sort of worded sort of problems that deal with exponential models. So the two models that you need to be aware of is exponential growth. That's when you use the equation y equals a to the power of x, where a is some number that's bigger than 1. And you've also got exponential decay, where you're using this equation here. So that's when you've got the negative version of x. But a is still some number that's larger than 1. Okay, so a typical example is, for example, a fish population. So fish population is going to increase over time as fish breed with each other. And you can model it using this equation here. Now, this equation here is an exponential model because of this power of t. So instead of an x, it's a t, but that's still a variable. Your variable is still a power, so therefore it is still an exponential model. You have to also be able to understand and deal with these numbers here, this 500 times and the 1.5. Okay, so let's see how we go. So this n represents the number of fish and t represents time. So first up, they want you to construct a table of values for t and n. So consider your n is like your y and your x is like your t. So pretty much they make this sort of table of values here. Okay, so they want you to do it from t values from 0 to 4. So you can see 0, 1, 2, 3, 4. So that's done correctly for you. Okay, so when you're figuring out your values of n, you are pretty much just putting these values of t up here into this equation. So for the first one, you can see that, okay, we want our, let's get rid of that. You can see for the first one, we want our t to be 0. So this t right here is going to change to 0. So this will end up being something like 500 times 1.5 to the power of 0. 1.5 to the power of 0, that's just 1. So 500 times 1 equals your 500. So that's pretty much how they're getting this table of values. And you continue that process and you'll get these numbers here. So that shouldn't be too bad. The next question, so before we move on, I just kind of want to explain to you what a few things that don't come up in this question here. But this 500 here is a particularly important number because it's the number when the time is 0. So another way to say that is like your initial amount. So initial when time is 0, pretty much meaning that at the start there's going to be 500 fish. So this 500 here is kind of indicating how many fish there are initially. So pretty much we're looking at this population. There's 500 at the moment, and we're multiplying by this because over time this 500 is going to be getting bigger and bigger exponentially. So really important that you realize that this 500 is all about the initial amount. Okay, and then you can see that after so it started out with your 500, then after 1 year it goes up to 750 fish, then after 2 years it goes up to this. It's getting bigger and bigger as time goes on. So that table of values actually does tell us quite a lot. Okay, so draw the graph for this. Okay, so obviously you need to make sure your scales are good for this graph. So here it's gone all the way up to 2,531. So, and they've actually gone up all the way up to 4,000. You probably don't have to go up as high as that, but you definitely need to go up about as high as at least 3,000 because you've got to get this dot in. So when you do your graph, it should look something like this. It should look something like an exponential curve as we did last lesson. Question C, how many fish were present after 2 years? Well, you can see right here at 2 year mark, there's going to be 1,125 fish present. How many extra fish were present after the 4 years compared to the 2 years? So you're just comparing the number of fish after 2 and 4 years. So the difference between those two numbers. Nice and simple. Estimate the number of fish after 18 months. So when you're estimating, this is where you want to be using your graph. So this is why we like to graph it, because it allows us to estimate for different times. So at the 18-month mark, so that's going to be equivalent to 1.5 years, because 6 months is half a year, so 18 months is going to be 1.5 years. So going up from 1.5 years, it's going to be approximately, looks something about 900. It's just a little bit under the 1,000 mark. And so here, their approximation is that 900 fish. So it doesn't that one doesn't have to be perfect, guys, but try to get something relatively close for your estimates. Remember, guys, it is just an estimate. It doesn't have to be perfect. Okay, so the questions in the textbook can get a little bit different to that, but let me know if there's any issues. I have a feeling you should be all right, but we'll see. Good luck with it all, guys. Bye.